so that we should see each other face, because it's important in the webinar, to see everyone. So, otherwise, it's monotonous. So request everyone to put their camera on. So welcome everyone to this very unique webinar by IEEMA Western Region, Decoding of National Electrical Code of India 2023. We have with us very eminent speaker, Mr. Gopal Kumar. I will definitely introduce him to all of you. Before that, I just wanted to touch upon the National Electrical Code, which was released recently. Everybody is aware. Uh, it's an all-inclusive electrical installation code prepared by Bureau of Indian Standards (BIS), which provides guidelines for the regulating electrical installation practices across the country. So basically, the BIS was the instrument in putting this National Electrical Code. Basically, the National Electricity Safety Regulation published on 8 June 2023 recently. National Electric Code of India 2000 is now mandatory. It's mandatory everywhere. It covers modern safety measures, including NCA Regulation 2023 and NES 2023. Before Gopal sir take you through this very interesting webinar, give you more in-depth knowledge about how this code, how we interpreted this code. I just like to introduce Gopal sir. Gopal Kumar sir is very active. He has been one of the pioneer in electrical safety and doing various webinars throughout India. He is member of ETD 20 BIS and president National Federation of Engineers for Electrical Safety. He is very active in IEEMA as well as various other forum. Gopal sir, over to you to take this forward. Before that, I just wanted to run across some of the housekeeping rule for this webinar, so that we can seamlessly have this webinar. Uh, uh, just a minute. Give me a moment. So before we start, just wanted to run across some of the housekeeping rule for this webinar. Please keep your microphone on mute all the time unless speaking to avoid any disturbance during the webinar. Please post your queries or question in the chat box window or use raise the hand function in the participant list if you want to ask question. But we'll take the question and answer once Gopal sir through. If there is something urgent, we can you can raise your hand and ask the question to our eminent speaker. In case you face issue related to audio or video, then check your internet bandwidth or reconnect using same link. In case of any technical or electricity glitch during the webinar, all attendees are requested to join using the same link within 1 to 2 minutes of disconnection. Thanks a lot. Over to you, Gopal sir.
Thank you, Rajesh. Thank you very much. I hope my sound is clear and
sir,
the voice is also clear.
Yeah, clear, sir.
No, I'm not on mute. I hope the sound is clear.
We are not able to hear you.
Sound clear, sir. Huh? Sound is clear.
Yes, my sound is clear. Somebody told.
We can hear him.
Audible, sir. Audible.
Thank you very much. Thank you very much. Thank you very much. Now let me share the screen. So participants, today we are going to discuss about the National Electrical Code of India, NEC, which is published during, one moment, there is a Only there is a small window which I wanted to hide. One moment. Okay. So hope the screen is in full mode. Hello, Mr. Rajesh.
Yes.
Yeah, thank you. Thanks to all. Thanks to all the participants. We have about 57 participants, including 2 of us. So today we are going to discuss about the National NEC 2023, which was published during January 6th of 2023. So today we have made the name as Decoding of National Electrical Code. The idea was to explain the participants what exactly is written in National Electrical Code. By the way, my name is Gopakumar. I am the member in IEC 64, which is a committee in the IEC, writing the standards for international standards for electrical safety, low voltage. TC 81 is the technical committee which writes the standards on lightning protection system and so on. Also, I'm a part of National Building Code Electrical Committee and the National NEC IS 732, IS 3043. All these are made by ETD 20. So before starting, let me switch off the camera because probably the bandwidth is much better. So today, the program is hosted by IEEMA, also supported by BIS and NFE. NFE is National Federation of Engineers for Electrical Safety. You are aware that the electrical safety situation is not very good in India. So we started this society to educate engineers what they should do, how they can follow standards. Now, the situation about electrical safety is very well aware to people like you. Yesterday, there was an electrocution. All of you know, a transformer busted and about 16 people passed away. Then yesterday, there was another incident where an air conditioner caught fire in a sugar mill and the instrumentation and the electrical HOD. He passed away while he was taken to the hospital. And the reason was he inhaled some gas which was coming out of the smoke. So almost every day this is happening, not 1 or 2, but several all over the country. 2016, there was a Japanese delegation who made a presentation in CEA. All of you know CEA, Central Electricity Authority. So today we will be also talking about the new regulations, the CEA measures relating to safety and electric supply 2023 regulation. So now on this presentation or the study report published by this gentleman, Mr. Takashi Honda. So this was on 12th April 2016. According to him, you can see on the graph 723. This is the number of people, those who are electrocuted or died due to shock in India out of 100 million population. That means 723 out of 10 crores people, approximately 12,000 to 13,000 people per annum is getting killed in India due to shock alone. The average of the other countries you can see, Japan stands leads, it's only 12. We are 723, very much higher. The same delegation also made a kind of a survey and they published a safety score. Out of the survey, out of G20 nations, India got the least score in electrical safety, 16%. Actually, in our NFE, we have got a few WhatsApp groups and every day, a lot of technical discussions are going on in our group. So the final result is the understanding about electrical safety within the country itself is very poor. Here, the Japanese average during 1940s, 1950s was about 600 people out of 100 million population per year, and they have reduced it to almost 12, almost nil. Whereas in our case, we are still at 723. We should also consider that only 50% of the cases are reported in India. Not all the cases are reported. The case reporting system, I hope you are aware, through the panchayats, through the National Crime Records Bureau, they collect the data. Then similarly, the Electrical Inspectorate also collect the data. And finally, these data are compiled and published by NCRB. whereas only about more than 50% of the accidents are not really reported, probably. This video, I'm sure most of you must have seen, but this is a live video which happened, a fire accident which happened in a hospital. Anyway, for the information of others, I'm just showing it. This happened in the hospital in, I just put the, so basically this is the situation. I can show you hundreds of such videos, but that is not the point here. So now, because of these accidents, I'm sure all of you are aware that the CE regulations has been published in June 8th. It was gazetted on June 8th, 2023. The new regulations and the new code of practice had made a lot of changes with respect to electrical safety. If you look also, if you look at the overall scenario of electrical accidents, about 50% of the accidents are happening within the consumer premise. About 48% happens in low voltage distribution, low and medium voltage, maybe less than 33 kV distribution, and about 2% happens on the extra high voltage area. So there was a move to make or to change the regulation and the standards in this particular area. And now the new regulation and standard has come out beautifully with a lot of changes. Of course, further improvements are also possible, but a lot of changes have come, which is going to bring the situation to a different level. Now, if you look at the hierarchy of electrical safety, you can see that at the top we have the Electricity Act 2003. The Electricity Act is the correct name, 2003. Then we have the Electricity Act. According to the Act, the regulations are made by Central Electricity Authority, and the regulations are called as Measures Relating to Safety and Electric Supply Regulations 2023. As I said, it was published during June 15th or June 8th. It was gazetted, but it officially came out on June 15th to our hand. Now, one important change which has happened is in the regulation, earlier regulation 12 and the new regulation 14. I will come to it later. Now, under the regulation or based on the regulation, the code of practices are made. National Electrical Code is a code of practice. Under the difference between code of practice and standards are, code of practice are not product specific. It's an installation standard, or it's an installation rule which has to be followed in a to make a very safe electrical installation. The example of code of practices are National Electrical Code 2023, National Building Code, IS 3043, which is code of practice of earthing, IS 732, which is code of practice of electrical wiring, and so on. Under that, we have the standards, which is the product standard. For example, the product standards for wires, cables, light fittings, switches, switch gears, panel boards, and so on. These are standards. So a product has to be selected and erected based on the code of practice, and it has to meet the performance requirements set by the code of practice. Then after that, we have the operational documents. Operational documents explains you.
Sir, not audible, sir.
It's audible. Just unplug your audio and again restart.
Sir, not audible.
Because everyone is able to hear. I don't know. So what I request you, just exit out and again you log in. Sir, you can start.
Yeah, thank you. So operational documents explains how to operate and maintain an electrical installation safely, such as permit, work, supervision, PPEs, instructions, and so on. So this is the overall hierarchy of the electrical safety scenario.
The slides not changing and not audible, sir.
Slide is changing only now. Audible if it's audible to others.
It's audible to everyone, sir.
Thank you.
You are very well audible, sir.
So
audible,
very,
sir.
yeah, now it's audible.
Now audible, sir.
Okay, fine, fine. Thanks.
So now what we should understand is in a lot of cases, we still use the IE rule 1956. Please note that IE rule 1956 is already replaced by CEA measures relating to safety and electric supply regulations 2010. Now the 2010 regulation, which was amended in 2015, 2018 and 2019, altogether is completely changed to a new regulation, which is the Central Electricity Authority measures relating to safety and electric supply regulations 2023. It came into effect on 8th June 2023, which is, very, very new. Now, if you look at the Electricity Act section 146 explains about the non-compliance, the penal provision in case of non-compliance of the regulations and the code of practices, or whatever rules and regulations made by the government of India under the Electricity Act. If they are not followed properly, then the section 146 says shall be punishable with imprisonment for a term which may extend to 3 months, or with fine which may extend to 1 lakh rupees, or with both in respect of each offense, and in case of a continuing failure with an additional fine which may extend to 5,000 rupees every day. So the Act has got a provision to penalize who is penalized. This is also a question. There is a definition for that. The owner, the director, the managing director, or the chairman, or the manager in charge of the factory or the industry. So everybody is liable, especially not the low-level employees, but the higher level management is responsible in case of any accident. And this section 146 is becoming important now, because until now, most of the government organization or government mechanism was not following section 146, but now the recent accidents, they started applying the section 146. The result is, you must be aware that yesterday's accident, I think 3 or 4 officers were put into jail without no questions asked. If there is an accident, electrical accident, and if there is a proof that the accident is due to non-follow-up of the rules and regulations, the straight route is written in section 146. So it is time to be aware of this particular regulation or the act. Now I will go through a little bit on the regulation and then go to the NEC, because the regulation finally is going to influence the National Electrical Code. Now, in the regulation, you can find these points. For example, definition. In the definition, you see here, one of the confusing subject, earthing. I'm not going through all the definitions. Few of the definitions got changed, and one of the major change happened in earthing. You can read here. Earthing means the connection of exposed conductive and extraneous conductive parts of an installation to the main earthing terminal of that installation. So the first definition is, you can see on the the ZB and ZC, exposed conductive part means a conductive part which can readily be touched and which is not normally live, but which can become live under fault condition. That means it is the body of a panel board. Extraneous conductive part means a conductive part not forming a part of electrical installation.
Sir, voice breaking, sir. Unable to.
I think, gentlemen,
The
it is
voice
only
is
your
breaking
problem.
continuously.
In that case, probably you can check your internet speed.
Mr. Govindarajan,
Sir, not audible,
I
sir.
think It's your problem, Mr. Govindarajan. I request you to check your audio or you just exit out and again log in, after checking your bandwidth. Because everyone else is getting very good audio. So there is some bandwidth issue from at your end. So you can continue, sir. Very sorry.
Yeah. So see these definitions. Exposed conductive part means a panel board body. Extraneous conductive part means a metallic, other metallic objects in a particular location. So now you see the definition of earthing. Earthing means connection of exposed conductive and extraneous conductive parts of an installation to the main earthing terminal of that installation. So what is main earthing terminal? Main earthing terminal, there is a definition. It says it's a bus bar. Earthing means connecting exposed and extraneous conductive parts to a bus bar. So this definition is going to have a major change in our life or in the practices of electrical installation. I will explain it later. Then, or connection of neutral of transformer or generator or equipment to general mass of earth or earth bonded bar of that installation. For example, here, general mass of earth is also written here. If you have a transformer which is for public electricity distribution, then you have to connect to the general mass of earth. If it is an industrial premise, then you have to connect to the earth bonding bar. So basically, this is a big change in the definition. Number two, earthing arrangement or earthing system means all electric connections and devices involved in the earthing of a system and installation or equipment. So basically, like this, the entire definitions are being modified. I don't go through the other definitions. Probably once when you get the slide presentations, you can go through it later. Now, earlier, the chapter 3, regulation number 12, this was saying, save otherwise provided in this regulation, the relevant code of practice of Bureau of Indian Standards or National Electrical Code, if any, may be followed. The wording which was used in the 2010 regulation was may be followed. May, the word may is a recommendation. Whereas in the new regulation, the number has changed. The same regulation has gone to 14 because 2 more regulations are included in between. Now the new number is regulation number 14. And you see the sub-regulation number 2, save otherwise provided in these regulations, the relevant standards, including National Electrical Code and National Building Code, shall be followed to carry out the purpose for the purpose of these regulations. So basically, the Central Electricity Authority made compliance to National Electrical Code and National Building Code shall be followed, means mandatory. It's a requirement. Requirement means it's a mandatory requirement. This is actually a big change. Until now, if we look at NEC, then people say, oh, this is only a recommendation. We don't need to follow. But that is not the case now. And whenever relevant Indian standards are not available, international standard, there is a definition for international standards as well. But anyway, all the practical requirements are covered in NEC and National Building Code. Now, sub-regulation 3 says materials and apparatus shall conform to the relevant standard. Relevant standard is IS standard. These regulations, let me skip the regulation 16, 17. This is mostly applicable for the consumer premise by the DISCOM. I'm sure some DISCOM engineers are also there. So if DISCOM engineers are there, I just let me explain. For example, the earlier regulation 16, the current regulation 18, earthed terminal on consumer premise. The supplier shall provide and maintain on consumer's premise for the consumer's use a suitable earthed terminal in an accessible position at or near the point of commencement of supply as per the relevant standard. So the change is the relevant standard. IS 3043 explains how to make it. So there is a little bit change in this particular case, and provided in that condition of installation voltage exceeding 240 volt, just to look at the place where I have highlighted. The same shall be interlinked with the earth terminal mentioned in sub-regulation 1 through a suitable link. So basically, the earthed terminal requirement means from the transformer. This is applicable not for our own consumption. This is for DISCOM, distribution company. So what does this mean is, at the consumer premise, the DISCOM shall provide a terminal, which is called as earthed terminal. In order to call it as earthed terminal, the DISCOM has to connect the earth bus bar at the consumer premise to the neutral of the transformer through a metallic connection. It is not to the earth electrode. It is earthed terminal means this terminal is connected to the neutral of the transformer through a metallic path, so that in case of any fault, the fault current returns back through the metallic fault return path. So that is how it changed. Similarly, periodic verification, again, it is the responsibility of the DISCOM. Of course, earlier, the DISCOM, every 5 years, they are supposed to check the insulation resistance of the installation. Whereas most part of India, these checks are not made, especially for low voltage electrical installations by the DISCOM, mostly not carried out. So all these are again repeated here with some small changes, which says these tests shall be made as per the relevant standard. Testing at consumer premise.
Just coming in, Chandrasekhar this side, just a small query on this. Because we do solar projects in Odisha, and when it comes to the net metering thing, the safety standards are asked by the electrical inspector on the DISCOM side as well as the consumer side. But the earthing thing that you said, was it not there earlier, or it is introduced just now, or it was there, it was not complied, and now it is compulsory?
It was there earlier also, but it was misinterpreted all over India.
Okay. So the interpretation would be like, as you said, a separate terminal with a conductive material will be connected up to transformer.
For example, this is called as a TNCS system. In a TNCS system, the connection, let me see whether I have a picture. One moment, please.
Thank you.
I think I don't have a picture right now, but probably after the program I can show it to you.
Yeah.
So there is a change. Earlier also there was no, the meaning was correct, but this time it is more clear. It is a little bit simplified.
Okay.
So now, testing at the consumer premise, the testing and verification shall be carried out as per the relevant standard. So the relevant standard here is National Electrical Code. Testing and verification, which is already included in NEC in Part 1, Section 17. That means the safety audits which you were doing until now, like the earth pit resistance measurement and all those things, you have to do it as per Part 1, Section 17 of NEC. Now, for your information, earlier we had all safety audits or verification means first inspection which we do was generally the earth pit resistance measurement. And the funny part is the earth pit resistance measurement has been thrown out of the standard. It has been removed from the standard. You don't need to carry out this particular test anymore because earth pit resistance has nothing to do with safety. So I will come back to it later. But anyhow, this is how we should make it. Precautions against leakage. Again, this is applicable for a DISCOM. Now the relevant standards are being included. Now this is Regulation 38, a very important regulation. This is for multi-storied buildings. More than 15 meters height, this regulation is applicable. Now, the sub-regulation 3 gives a definition what exactly they mean. It means any building more than 15 meters height and all buildings such as airports, hospital, hotel, place of entertainment, place of worship, cultural heritage, cultural center, stadium, academic building, test lab, industrial installation with explosive, flammable material, railway or metro stations and other public buildings. So all these buildings which is written here, starting from airport up to public building, irrespective of height, and all the other buildings with more than 15 meters height. Technically, what will happen is all residential buildings more than 50-meter height, and all the other kind of buildings, all the other buildings like a hotel, hospital, airport, temples, place of worship, cultural center, stadium, academic building, test labs, industrial installations. So all these things, the regulation 38 is applicable. Here you see, the owner or occupier of a multi-storied building shall ensure that electrical installation and work inside the building are carried out and maintained in such a manner as to prevent danger to shock and fire hazard, and the installation is carried out as per the relevant standard. So this is again the relevant standard is National Electrical Code. So similarly, sub-regulation number 6, lightning protection shall be as per the relevant standard, which is nothing but IEEE 62305 or the National Building Code of India. Verification of electrical installation shall be carried out as per the relevant standard. Here again, the National Electrical Code comes into picture. As I said, the Part 1, Section 17 of NEC explains about verification. And one of the very important verification is the earth electrode testing has been taken out of the standard because this was a big misinterpretation. Now, the regulation number, the old regulation 41, new regulation number 43, connection with the earth. The majority of us were making the mistake, the two connection, two earth electrode for neutral, two earth electrode for body, then for each DG, two. So all these things are gone. The sub-regulation 1 says the neutral conductor of 3-phase 4-wire system and the middle conductor of a 2-phase 3-wire system shall be earthed as per the relevant standard. Here also the National Electrical Code comes into picture. Now, very important, please note this. Every building shall have protective equipotential bonding by interconnecting the exposed and extraneous conductive parts as per the relevant standard. Every building, irrespective of the size, every building shall have protective equipotential bonding by interconnecting exposed and extraneous conductive parts as per the relevant standard. I just show a picture how it looks like. So, for example, you can find this picture also in the NEC Part 1, Section 18. For example, in your building, you have exposed conductive parts. Examples are panel board body, motor body. All these are technically called as exposed conductive parts. You look at the definition for more information, please. Similarly, your building has got, let's say, metal pipe. Example, the firefighting pipe. Also the constructional steel, down conductor of lightning protection system, continuously connected handrail, the aluminum frame of a glass facade which is on the building. All these are called as extraneous conductive parts. You have an MET in your building, means a common bus bar. The exposed conductive parts are connected to the bus bar, and this is called as protective earthing. Sometime in the other countries, it's also called as circuit protective conductors. Basically, all the exposed conductive parts are connected to MET. All the extraneous conductive parts are also connected to MET. This is called as protective bonding. So protective earthing is number 1, protective bonding is number 2. Then the MET is connected to an earth electrode in soil if you have a TT network. Similarly, the MET is connected to the neutral of the source, means from the MET directly to the neutral of the transformer in case of a TT system, in case of a TN system. So if you are going for a TT system is applicable for public electricity distribution. So then only you need an earth electrode in soil, mandatory. If you go for a TN system, then this is not required. So industrial and commercial premise, technically it's a TN system. So the story of earth electrode is kicked out of both the regulation and the standard. We will come back to you. I'm sure sometime you are confused. I will come back to you later. Similarly, your building also need supplementary bonding. Supplementary bonding, for example, the panel board body and the motor body is connected. The motor body is again connected to, for example, to a pipe fitting and so on. So these are supplementary bonding, and all these connections together are called as protective equipotential bonding. Means every building, be it an industrial building or commercial building or residential, whatever, all the metal parts must be interconnected to a common bus bar. And for making this connection, several rules are applicable. It is not like you take a wire and interconnect everywhere. Several rules are applicable. Now, what the regulation says is every building shall have a protective equipotential bonding by interconnecting exposed and extraneous conductive parts as per the relevant standard. Here, the relevant standard is National Electrical Code. So the problem is most of the buildings in India, this measure called as protective equipotential bonding is not carried out properly. In case of any accident, I don't know what is going to happen. Now the electrical inspectorate engineers are also getting educated. Next time they may not ask you the earth electrode requirement or earth electrode resistance. They will ask you to show the protective equipotential bonding, and if it is not existing in a factory, then and in case of an accident, this can be treated as an offense. Now let me go to the next one. This is about the frame of generator by two separate and distinct connections with the earth. This is not to earth electrode, this is to earth, means the common bonding bar. Then this one, very, very important sub-regulation. Earlier, it was limit the earth resistance sufficiently low to permit adequate fault current for the operation. So earth resistance has been completely changed to have earth fault loop impedance sufficiently low to permit adequate fault loop fault current for the operation of protective device. The concept has been completely changed. Now the new rule and regulation, also the NEC, the concept of this earth pit resistance has been taken out of the standard, and the entirely the fault loop impedance is included. Please note that this is not a new requirement. This has been included in the older versions of NEC and IS 732 as well, but we were not practicing. But now with the very specifically, it is included in the regulation. That means the electrical inspectorate also will start asking for this test report, for example, in future. Similarly, the sub-regulation 11, sub-regulation 12, 11 says the earth fault loop impedance shall be tested to ensure automatic operation of protective device, and a record of every test made and the result thereof shall be kept by the supplier. This 11 is applicable for the supplier, means the DISCOM. And here the number 12, earth fault loop impedance of each circuit shall be limited to a value determined by the type and the current rating of the protective device. Basically, this regulation 12 explains about the responsibility of the user or the consumer. Similarly, neutral point of every generator and transformer shall be earthed by connecting it to the earthing system by not less than two separate and distinct connections. Please note the definition of earthing system. Earthing system, I show you the definition once again in order to clarify it better. You see here, earthing arrangement or earthing system means all electric connections and devices involved in the earthing of a system and installation or equipment. So these are nothing but the electric connections between different metallic parts. So basically, neutral of the transformer or neutral of the generator has to be connected to the neutral point of every generator and transformer shall be earthed to the earthing system, means an interconnected metallic bus bar. So this also has changed. Similarly, earlier the earth leakage protective device, this is changed to RCD, residual current device. This is the correct name. Now, if you look at the first two paragraphs, it says an RCD is required at every consumer premise, and for residential domestic installation, 30 milliampere RCD is necessary. And the third paragraph says, provided further that such protective device shall not be required for supply lines having protective device which are effectively bonded to the neutral of the supply transformer and conforming to regulation 76. So the third para says, if you have a TN system, then you don't need any RCD. So the first two says, if you have you have to use an RCD. in all electrical installation. So whenever you start using, that means at the main switchboard, you have to have an RCD of 30 milliampere. Now, this third paragraph says if you go for a TN system, you don't need to have an RCD. So indirectly, what it happens is, if the supplier or if the discom or if the consumer uses technically a TT system, at the main distribution board, you have to use a 30 milliampere RCD. And if you use a TN system, either TNC, TNS, TNCS, then you don't need to use a RCD. So these are actually some of the changes which is going to have a large influence. Now let us go to the National Electrical Code. I hope whatever I explained is clear for you, and my sound is also clear. Mr. Rajesh, can you confirm the sound?
Sir, can I ask one question?
Yes, sir. Sounding very good.
Sir, in TN system, why RCD is not required?
Because the earth fault loop impedance is low enough to disconnect. The MCBs will work in case of an earth fault.
But in the individual consumer, that MCB will not be there. With the
Or the cutout fuse is there. The cutout fuse will disconnect the supply. Every consumer premise, there is a cutout fuse. Am I correct, sir? So that cutout fuse, the discom has to test the fault loop impedance and ensure that the cutout fuse is disconnecting the supply in case of any fault within the consumer premise. So now let me go to the NEC. I will come back to this question because all over India now these questions started, people started asking the question. We will clarify all those questions. Now NEC. This was published in June 6th, 2023. Very new document, only 6 months old now, 6 or 7 months old now. Now, if you look at the standards and the code of practices made by BIS, you can find the standards relating to different kind of products such as VCBs, VCB panels or transformers, UPS, busbar trunking, cables, junction boxes, switch gears, panel boards, motors. All these are there in the form of standards. The first point which I wanted to stress is NEC is not a product standard. NEC do not talks about, for example, the performance of a motor or how the performance of a busbar trunking, testing of a cable. All these are not included. The performance requirement of each product is not a part of NEC. NEC is a standard or a code of practice which explains selection, erection, and verification of installation focused on safety. So basically, it talks about the electrical installation. NEC talks about normal installation. NEC talks about special installations such as bathroom, medical, heating, street light, outdoor, also about DG, UPS, solar PV, power quality, energy conservation, lightning protection, etc. So all these are covered in NEC. Please note that functionality of modern electrical appliances is not included in NEC because functionality, that is a different subject altogether. NEC is more focused towards safety. People always ask, generally, once when we make trainings, the question which comes is, why do we have so many standards, several rules, regulations, act? You see, we are talking about electrical engineering, which is a very, very vast subject. For example, if we look at power quality alone is a subject of its own kind. There are about 100 standards on power quality. So the subject which we are talking is a big subject. Each of the subject has got its own standards, test parameters, quality requirements, and so on. So basically, NEC is not a product standard, it is a installation standard. Similarly, IS 732 is also an installation standard. So the first NEC was published in 1985, the revision was published in 2011, and the new revision is in January 2023. It explains good practices for selection of electrical equipment forming part of electrical installation, safety in wiring, in the wiring of electrical installation, and general safety procedures. These are the contents of NEC. The standard is, or the code of practice is prepared by ETD 20, which is the Electrotechnical Department 20 of Bureau of Indian Standards, where I am a member. We started this process during January 2020. In fact, it's not exactly January 2020. During 2019 itself, the work started. Now the NEC is mandated for implementation by Central Electricity Authority safety regulations. So there are more than 100 people working in this particular committee. It has got 8 parts and 49 sections, 8 panels, and 50+ meetings of experts happened in the last 2-3 years. And finally, we came out, or we could publish it in January 2023. So it consists of 8 parts. The first one talks about general and common aspects, which consists of 22 sections. Part 2 talks about electrical installation in standby generating stations and captive substations, basically generators and captive substations. It is consisting of 2 sections. Part 3, electrical installation in special installation in the sense, anyway, I have the explanation, I will explain it later. 22 sections are there. Industrial building part 4, outdoor installation, 3 sections in part 5, agriculture premise in part 6, hazardous area in part 7, solar PV in part 8. These are the main, this is the structure of National Electrical Code. Now, if you look at part 1 talks about the general requirement, general and some kind of a specific common aspect. The part 1, in the initial section 1 to 8, the scope of NEC, exclusions, definitions, and fundamentals of terms, basically up to 8, much technicalities are there, but informative things are there. Section 9 talks about wiring installation, how to select a wiring, how to erect a wiring, what kind of wires are required, how to coordinate between civil work, architect, civil construction, and other building services, and how to make especially the wiring, how to assess the load, how to make a circuit diagram, how to select the cable, protective devices, method of construction, and all these are explained in section 9, and we call as wiring installation. Then we go to the section 10 to 13. It provides the fundamental requirements of safety. Fundamental requirement in the sense basic requirements of safety. Section 10 explains about protection from electric shock. Section 11 about thermal effect means fire. Section 12 about overcurrent, and section 13 about over voltages. Section 14 to 16 provides the calculation of short circuit current, the impedances, voltage drop, electrical aspects of building and services. Section 17 is an important section which guides you, check various points enlisted there in test procedure with model forms for reporting. Section 17 is talking about verification of electrical installation. Verification in the sense, verification consists of inspection and testing. Both are included. Sometimes people ask, why audit? Actually, we don't use the word auditing in the standard because auditing is a job which is carried out on sampling basis. Auditing is not carried out in all the circuits, whereas verification is much clearer word. Verification consists of inspection and testing, and verification has to be carried out in all the circuits because we are talking about safety. Section 18 talks about earthing. So part 1, section 18 is about earthing. Now here in this particular part, we have made some simplified drawings, some charts, some tables. If possible, I will go through it by opening the file so that you will be able to understand it. Section 19 on lightning protection, section 20 on power quality, section 21 on energy efficiency and optimize the use of energy. Section 22 talks about safety in the during work, or during while somebody, when they work on electricity, how to make the area safe. So basically it consists, you can see here, section 1, scope of the NEC, section 2, definition, 3, graphical symbols, 4, preparation of drawings, charts, tables, and marking, number 5, units and systems of measurement, section 6, standard values, 7, fundamental principles, 8, assessment of general characteristics of building, 9, wiring installation, 10, protection against electric shock, 11, protection against thermal effect, 12, protection against overcurrent, 13, protection from over voltages, 14, short circuit, 15, electrical aspects of building service, section 16, selection of equipment, 17. So like this, that there are 22 sections in the NEC part 1 alone. Out of this, probably the section 17 is very important, because the national safety regulation has written to follow these testing procedures in the regulation. So this is becoming important. Also, the earthing is also becoming important. It doesn't mean that the others are not important. Every part is important. Part 2 consists of electrical installation in standby generating sets, and section 2 talks about captive distribution substation. So if you have a substation in your premise, the respective measures can be found in this particular section. Please note that section 2, captive distribution substation, means it talks only about the area requirement for the distribution substation, not about the whole building. Part 3 talks about special location. Here, part 1 is general location, part 3 is special location. The idea is every building has got some kind of special location. For example, in a house, bathroom is a special electrical location because it's a wet area. People can get the shock, electric shock, very fast, more than in the other area. So wet areas has to be treated very differently. Similarly, for example, office buildings, hotels, hospitals, electrical installation, multi-storied building, all these additional locations are included in the part 3. Say, for example, if you have a hospital, or if you wanted to make the electrical design of a hospital, you have to comply to all the parts of all the sections of part 1 and part 3 section 9. Part 3 section 9 talks about medical location. Medical location in the sense the operation theaters and the ICUs, group 0, group 1, group 2 medical location. So these are also important. Here, the special location, you can see the list of special locations: domestic dwelling, bath or shower, swimming pools, the location having sauna heater, demolition sites, construction sites, restricted movement, places with restricted movements, then camping parks, marinas, medical location, exhibition, furniture. So like this, there are 22 sections in part 3. Then we go to part 4. Part 4 talks about industrial building. It covers the electrical installation in industrial building. It comprehensively classifies the type of industrial building based on fire safety, power consumption, and pollution level. Also, requirements related to industrial substation, wiring system, earthing, fire safety requirements, and building services. All these are covered in part 4, industrial building. Part 5 talks about the outdoor installation. Here, the subjects covered are public lighting installation, temporary outdoor installation, and permanent outdoor installation. These, special requirements such as requirements against dust, water, rainwater, then seasonal conditions, ambient temperature, all these are included in addition. Part 6, agriculture and horticulture premise, because where the presence of livestock and other external influences like presence of water, foreign bodies, corrosive or polluting substances, flora, fauna, all these are located in these areas. So those special requirements are included in part 6. Part 7 talks about hazardous area. Hazardous area, all of you know, zone 0, zone 1, zone 2, hazardous area, and the electrical requirements in that area. And the part 8, which is the last part, which talks about solar PV installation. Of course, for medical, for EV charging, there is already a section in part 3. So part 8, part 3, one of the section is talking about EV charging. So part 8 talks about solar photovoltaic. All the requirements of solar PV are included in part 8. So this is about the overall structure of National Electrical Code. So now, basically, I will go through the different requirements of NEC in the next slides. So what we have seen so far is the presentation started with the hierarchy of electrical installation or electrical safety. The electrical safety, the most important is the Electricity Act, which is passed in the Parliament. Based on the Act, the regulations are made by Central Electricity Authority, and based on the regulations, the code of practices and standards are made mandatory. So basically now the structure of the legal system is in place properly for the first time in India. For the first time, why I mentioned it is because earlier the regulation has made code of practice and standards may be followed. It was like a recommendation, but now it is made mandatory. So this is going to have a big change in the system. We also saw some of the regulations, such as the testing of the installation shall be carried out as per the relevant standard, regulation number 39. Also, we saw the regulation number 14, which says the National Building Code and National Electrical Code is made mandatory. Similarly, the earth electrode resistance has been replaced by earth fault loop impedance. Similarly, earth fault loop impedance has been included in several places, and so on. So basically, a lot of changes happened in the regulation. Then we saw the National Electrical Code, NEC, and the different parts of NEC. So NEC, please note that NEC is now a legal requirement, and NEC is not about an electrical product, but NEC talks about designing, selection, erection, and verification of an electrical installation. Verification consists of inspection and auditing. So if you have any questions, probably we can have a small question answer session, maybe for 15 minutes, and then go ahead. Mr. Rajesh, I hope you are also on the...
Yes. So anyone have any particular question on so far whatever covered by Gopal Kumar sir?
I have one.
Yeah, please go ahead.
Can I share the screen? See, TNS systems.
You wanted to share the screen?
Yeah. I am just sharing from the IS 2043. 3043. Can you allow me sharing screen?
1 minute. Just give me a moment. Santosh, you're there? Let me try and give you rights.
Oh, I am the host. We have to Mr. Naresh. Am I correct, Mr.
Yeah, Naresh, you are
share?
the host, sir. You have to give. I'm
okay,
a co-host.
Okay, Mr. Naresh, you can share now.
Yeah. See, this is the diagram of the Indian Standard 3043 TNS system. Can you see, sir?
Yeah, we can hear. We can see that.
See here, what you have mentioned is that now onward क्या होगा कि भाई आपका equipment का जो earthing system है, मतलब जो bonding है, वो direct neutral से connect हो जाएगा.
Correct.
Right? But in this system also, they have provided provision for the earthing at the neutral also, and at the same time earthing at the equipment also.
No, that is only a symbolic representation of making a bonding. Symbolic representation of making the potential of those two places equal. That's all. or symbolic representation of protective earthing.
No, at some point they have also written that at the every entrance of the building, matlab, wherever supply is coming, they have to have an earthing systems, earth electrode. See, notes, read the notes written below. All exposed convert the installation are connected to protecting under by earth terminal of installation. An independent earth electrode within the consumer's premise is necessary. See here.
Yes.
Specifically written earthing
At the meter board, this is what is written in the regulation 18. For three-phase consumer premise, the MET or the terminal has to be connected to an earth electrode as well. But the problem is, for industrial and commercial premise, most of the installation or large number of buildings in India are following neutral, for example, 2 copper plate and body 2 GI pipe. For main panel, 2 more GI pipe. For lift, 2 more, UPS 2 more. Those are never written in the standard, and those things are removed from the very clear clarity is given. As a result, such mistakes cannot happen in future. Now, can you share, sir, can you search fault loop, for example? Control F. Fault loop, FAULT. Loop. You see, it is written in how many places? 66. If you delete one line, P, if you delete, then it comes
33.
Yeah, about 33 places. See, this one is talking about the purpose of earthing. You have to, the continuation is before the picture. Before the picture, you have to scroll down a little bit more. Yeah, you see, the purpose of earthing. A, provide a low earth fault loop impedance to facilitate automatic disconnection of supply in the event of a fault to expose the conductive part. The first job of earthing is to make a low impedance fault return path. Now, if you can go to the next, actually this subject has been explained in several places in the standard, and it is also written that during design, it has to be calculated. During safety audit, this has to be tested. All these parameters are there, but we were never doing this fault loop impedance in our system. If you further search, I can show you where these are written.
No, I got this, but total elimination of the earthing electrode,
yeah,
is not here written in TNS system in IS.
No, that is, you see, it is a 2019 document. Every time, once when a new document is published, there are some changes, improvements. Now, IS 3043 probably will be revised in next 1 or 2 years. We started the work. It will take some time. In the next revision, these pictures will be changed. Do you have a National Electrical Code NEC with you?
No.
Okay, so can I go to the next gentleman who has raised the hand? Mr. Naitik?
Naitik, you can go ahead and ask your question.
Yeah, thank you, sir. Gopal sir, good evening. My question was that now, as you have shown the slides, I could read that the Central Electricity Authority mentions the use of low smoke, low halogen, that is basically FRLS material for high-rise building above 15 meters in height. And as you rightly mentioned, that it is a mandatory practice it is mandatory and penalized if it is not followed. But on the other hand, I just wanted to understand this one, absolutely. Point number 4 on this slide, sir. So it mentions any building above 15 meters has to be low smoke and low halogen power cable, and public buildings, what I understand, airports, hospital, hotel, irrespective of height, has to be with HFFR, halogen free flame retardant. But on the other hand, the National Electric Code of India, that's section 22 in part 3, mentions the use of halogen-free flame retardant, HFFR material, for any high-rise building above 24 meters in height. So now an electrical inspector, when we talk with them, basically creates a confusion that what is to be followed, because they give more priority to CEA. I mean, they have been following CEA, and they tell that it mentions FRLS above 15 meters, not halogen free for high-rise buildings, which is in contradiction to NEC. So if you can throw some light on this so that we can respond to their queries.
Very simple, very simple, very simple. In the event of any inconsistency, the provisions of these regulations shall prevail.
Okay.
So the regulations are valued. In case of such confusions, you should refer to the regulation.
Okay. So so in all those such cases, NEC will be practiced, right?
Yeah, NEC, no, regulation will be practiced.
That is CEA.
Yeah, CEA regulations will apply. This document will be referred.
Okay, okay, okay. Because I could also gauge similar contradiction in the CR value, where CEA mentions of all the CR values of class 5 conductor, whereas the NEC talks about the CR values, conductor resistance values in wires of class 2 conductors for all the high-rise buildings, for all the fixed wiring, I mean to say. So that is also a contradiction. So in all such cases, CEA shall be valid, right?
Now, in CEA regulation, these resistances are there anywhere in the regulation?
I don't actually recall the part number or the clause, but the electrical inspector, what they have, what we have been in conversation with, they informed of a table which I'm not able to right away recall, and they mentions of all the resistance values of class 5 conductor, which is again contradictory to NEC, which talks about all these CR values, which is very close to class 2.
No. The resistance values of the wires are not at all included in the regulation.
Okay.
It is never, it is not there in the regulation. Now, electrical inspectorates have their own diary. It is not an official government diary. Almost all the states have got the Inspectors Association.
Okay.
So annually they print a diary and they put some technical information which is for ready reference. Probably in maybe in those diaries they must have put. I am also not aware.
Okay.
Now, imagine a situation where class 5 wire is included in the regulation and class 2 is included in the code of practice.
Yes.
And for example, somebody used the class 5 wire.
Yes.
So how it will be referred is your installation is not complying to the National Electrical Code. It is complying to Central Electricity Authority regulations. Now there is a conflict, and after in the next changes, this will be changed. You know, if we go into deep, there can be hundreds of conflicts, hundreds of confusions. It will be always there.
Okay, sir. Got it.
Yeah.
Thank you.
Thank you,
So,
Pratik.
Mr. CPR Pratik.
Yeah, hi. Good evening, sir.
Good evening, Mr. Pratik.
Like you said that the earth resistance testing now won't be asked, and it will be the earth fault loop impedance that will be mattered. So can I ask that what will be the standard limit for this earth fault loop impedance, and what is the procedure for testing this earth fault loop impedance?
Yeah. You can write down.
Yeah.
It is in IS 3043. I think the gentleman previously here, he was showing the IS 3043.
Okay.
If he can, Mr. Naresh, if you can share your screen, we can very quickly answer to Mr. Pratik's question. Is it possible? I stop sharing.
Yes, I can say.
Yes, please.
Are you able to see it?
Yes, we can see it. Just Control F fault loop.
1 minute.
No, this is something else, some other standard.
Yeah. Let me open it.
By the same time, I will also try to open the standards.
See, it is now said. Tell
Yeah.
me.
So
What-
can you please put the fault loop?
Okay.
Control F, fault loop. Yeah. So see these two places it is written. Now if you click further, further you can go down, next. See all these, for example, you see this 23.04, protective measure by automatic disconnection of supply following an insulation failure relies on the association of two conditions given below. The existence of a conducting path, fault loop, to provide for circulation of fault current. This depends on the type of system earthing and the disconnection of this current by an appropriate device in a given time. Can you further go, please? See here the calculations of fault loop has come into picture. ZS shall be ZS into the current which is acting the switch gear shall be lesser than the touch voltage. Now you can find a lot of explanations in this particular standard. Now if you wanted to find out how this is applied in a circuit, you can go to IS 732 1989 version or the latest 2019 version. Do you have IS 732?
Yes. I am just A732.
Yeah.
2019.
Yeah.
1 minute.
Here you again check a fault loop. The same thing that you have shared the correct file. Fault loop. Control F. So 62 places it's mentioned. Whereas the earth electrode resistance, earth fault loop impedance, here this is the definition. What exactly is this? You can go to the next. So this is also, all these explanations are there. Now, you see, this is the calculation, the same calculation which is there in IS 3043. Next,
Okay.
please. So here again the calculations. Next, please. Next, please. I will. Okay. See, measurement of for TN system, compliance of the rules, measurement of the fault loop impedance. See 6.2.3.6. So alternatively, the calculation of fault loop impedance also can be made. This is about the verification. If you scroll down a little bit up. I'm sorry, the opposite. Yeah, correct. Go a little bit more, please. So this IS 732 section 6 talks about verification, especially verification of the low voltage electrical installation. Here in this section, how to measure fault loop impedance is also included. Mr. Naresh, if you can press 2 times next, then it goes to that particular testing. Again. There is you see measurement of fault loop impedance. You see that there. Scroll little bit up. Previous. Somewhere I saw that it was there.
Is it?
Yeah, measurement of the fault loop impedance, clause 6.2.3.6. Now there is an annex, and you can refer to the annex, which is very well mentioned.
Here it is 6.
Yeah. Yeah. Now I will show it with a picture.
Should I now stop sharing?
Yes, please. So now, Mr. Pratik, your question is half answered. I will answer the balance. Mr. Alkendra Singh, you have any question? Mr. Singh?
Sir, you mentioned in the deep resistance has been eliminated. I mean, in case of earth electrode there.
If there is an earth electrode, you can keep it. No need to remove it. Let it be there.
Okay, no, in the new installations, when we are going to install a substation, we are generally providing separate earthing for neutral transfer earth and body earthing separate and lightning arrestor earthing separate. It was doing in our installations. And now what, as per NEC, we have to follow in substations earthing?
Sir, Mr. Naresh, can you share the IS 732 again, please? Sorry to disturb you. I am supposed to make the presentation, but I am asking your help because your file is open in your system. Can you scroll down to section 4.5, clause 4.5? 4.5, yeah. It will be almost half. Yeah. Next, protection against over voltage. Yeah. Now, if you scroll down. Scroll down, please.
Monik ji, if you could mute yourself.
Further. Further. There is one more again. I think 2-3 pages. After 2-3 pages. Again, further down. Further down, please. Actually, we have made these pictures. Now, further, I think next to 2 more pages. Again. All these pictures you can refer how to connect the systems. Again, these are explained. Where is it? Again, one more page. One more page, please. One more page, please. One more page, please. Yeah, this one. You see? Here, this picture is included in 2019 in the IS 732, just to tell you that this functional earth electrode separate, protective electrode separate, lightning protection electrode separate. This is wrong. That is why we put the cross mark. Separate electrode, this concept itself is wrong. On the left side, you have the correct concept. You see, there is a bus bar, main earthing terminal, protective and functional earthing conductors. All the earth wires coming from your building are connected to an MET. The MET is also connected to down conductors of lightning protection, joined for verification, and there is one symbolic representation of protective earthing. This is how it has to be made.
Okay, but in a 3-phase system, it was suggested earlier to provide double earth. So earth electrode will be a double electrode or single?
Mr. Can you go to the IS 3043, figure 14?
Okay.
You had IS 3043 in your.
1 minute.
Yeah.
Do you
Thanks,
need
Mr.
multiple
Naresh.
earth resistances of earth pits and then connected together to that MET, main earth?
One moment, let me answer one by one.
See, now it's 30.
You go to figure, I think figure 14. A little bit above. It was previous page. No. Below.
14 is here.
No, below. Again, some few more pages below. Few pages. Few pages.
But will it not create floating neutral issue if we are not connecting transformer neutral to the ground?
Yeah, few more pages. This is not the next is plate electrode. This is next one. I forget the name of the number of the picture. That's why I think now 3-4 figures you have to skip.
Actually finding, sir, what exactly you are looking for?
I am looking for the answer to the question, what is double earthing? There is a picture in the standard, because this is also this one. Now you see this. On the outer side, you are seeing the wall of the building. Item number 1 is the equipotential bonding conductor. Equipotential bonding conductor is the old name. Now it has been changed to MET, main earth terminal. It is nothing but a bus bar running all around the building along with your power cables and neutral power phase and neutral cables. One run. So item number 1 is the ring which is outside. And you see item number 2, protective conductor in duplicate. So M stands for exposed conductive part, means these are the major electrical appliances like panel boards, motor. When you connect it to the protective equipotential bonding, you need to make 2 connections. Example, on the cable tray, you have one run of bus bar. Once when you connect your panel board to the bus bar, you have to make 2 connections. You have to make an additional connection, duplicate connection. This is the meaning. And if you look at item number C, which is extraneous conductive part, which is metal pipe or whatever it is, those doesn't require 2 connections, only 1 connection is required. This is how it is.
I have one.
Hope the question is answered.
Request everyone to mute themselves one at a time, because otherwise it will get echo.
Okay.
So now let me go to the presentation, and I will continue the presentation for some more time and explain these with the picture as well as from the NEC.
1 minute, only one question. In continuation to this discussion, basically we are doing earthing in the neutral of the transformer so that in case of earth fault, that high voltage doesn't occur and insulation doesn't fail. There are basically 2 systems. Either you are unearthed system and earth system. Earth system means you are generator as a transformer. You are connecting to ground, matlab mass of the earth. Why? In case of earth fault, insulation failure will not occur. And in India, we have adopted system, neutral grounded systems. In your case, if we are removing that neutral, we will be in trouble then.
Nobody asked to remove. We have to earth it instead of an earth electrode.
Electrode is not required.
You wait. It is not to an earth. What I told is earthing is not required. I didn't use. I told earth electrode. So I am only saying earth electrode is the question. Now I will share my screen, but before that, let me open the NEC. One moment, please. Hope all of you have the NEC with you. I got the NEC. One moment. Now I am sharing the screen again.
I have NEC 2011. I don't have 2023.
No, this is you can download it from the BIS website at free of cost. Now yeah. BIS made all the Indian standards free of cost. You have to create a username, password, and download it at free of cost. So this is the NEC. I go straight to the section 18 or part 1, section 18. So this is the section. This section starts with the first picture is protective equipotential bonding. Actually, this picture is not invented by BIS. This is there in the 1960s of IS 3043. This was also there in the in the CPWD manual 2013. So the same picture is used here and the explanations are made here under. Then it goes to earthing of industrial and commercial premise. Only some of the selected wordings or selected sentences from IS 3043 are included here. Finally, the picture will be something like this. You have the transformer neutral, which is connected to an MET or to a PE conductor. So the installation equipment, you have an additional earth grid. So basically, this is how for the industrial system it has to be made. In the sense, the neutral of the system has to be connected to a metallic bus bar. And that bus bar has to extend up to the installation. All over the installation, that particular bus bar should run. Parallelly, the neutral is also connected to a grid. This grid is not, the grid is generally made by the steel which is used in the construction industry. For example, the metal columns, metal frames and all. In RCC building, the RCC, the rebars are made as a grid here. The MET is connected to the grid and the equipments are connected to the grid. So this is the new requirement. It is not new. In fact, it is there in the standard since long, but it is we try to make a picture. Similarly, for public distribution, clause number 6, earthing of low voltage electric supply by supplier. You can see here the transformer neutral is connected to an earthing electrode. In this particular case, public, the DISCOM, not the consumer, the DISCOM has to make the earth electrode. Then while in the distribution, you can see here additional earthing at distribution. The DISCOM is also supposed to make it 3 places in every kilometer. Then at the installation, origin of installation, there is a neutral terminal, there is an earthed terminal, and both has to be linked. And the earthed terminal has to be connected to an earth electrode as well. Then this is the TT network, and this is the IT network. All these are explained. Now, in a TN network, the neutral has to be earthed to the common bus bar, not to the separate earth electrode. If you connect it to the separate earth electrode, then the network becomes a TT network. So what is written in IS 732 and in IS 3043 and in NEC is, if you use a TT network, the origin of installation must have a 30 milliampere RCD. You can find it out in several places. Now the regulation is also following the same rule. Now coming back to the standard, see for example this one, Annexure A, example of earthing arrangement and protective conductors. This is from IS 732, this has been included here. You can also find this picture in National Building Code as well. Conductors and sizings are given here. Then Annexure C, erection of concrete embedded foundation earth electrode. So this is probably a new section. Then the global earthing system. Global earthing system, in fact, the entire details are not provided, only a small introduction. Global earthing system, if you are making global earthing system, yes, design complete. So for factory industries, you can go for global earthing system. Now, another information which somebody asked about fault loop impedance is here. I'm scrolling down now here, this one. Clause number 4.5 of NEC Part 1 Section 18. You see TN system. Earth fault loop impedance is important for automatic disconnection of supply during earth fault. The normal calculations are given. The IS 732 is asking a reduced value that is provided. Then finally, depending upon the MCB, the required fault loop impedances are also given as a table. This is the first time in the in any of the Indian standards, these informations are there. So you can very much make use of this information and make a simple. Now, similarly, if you go to the section 17 is explaining about verification, and what I'm scrolling is the format which is given. Let's say, for example, you are making an audit. So audit has to be reported in this particular format. So this format is there in Annexure D. Now in the format, you can find out one place you can find out earth electrode. It is nothing but the origin of installation. That means it is provided for if you are a consumer having a supply, LT supply at the origin. That means at the meter board, you need to have one earth electrode additionally. That has to be tested, but no specific values like 1 ohm, 5 ohm, 10 ohm is not mentioned anywhere. So you can make use of this format to make a safety audit. Of course, fault loop impedance, a lot of new testings has been included. Now let me go back to the presentation again. What exactly we are talking in this particular subject is, see, basically, every electrical network, there is a maximum disconnection time. The first job is, in case of any fault, before people get a shock, the supply has to be disconnected. So the full name of the safety measure is called as protective equipotential bonding and automatic disconnection of supply. In order to get automatic disconnection of supply, you can see here in case of a TN system, the final circuit 0.4 second, TT system 0.2 second. Similarly, the fixed installation 5 second and TT 1 second. These are the maximum.
स्क्रीन शेयरिंग बंद करना पड़ेगा. स्क्रीन शेयरिंग ही दिख रहा है अभी. प्रेजेंटेशन नहीं दिख रहा है.
Sir, you have to close now reshare. Mr. Monik Dalal, you can mute yourself because your audio is still on.
No, I have
Mr. Monik
shared.
Dalal. Thank you. Please go ahead, sir.
It is coming, right?
It's now proper. Yeah, it's
Actually,
now
your
proper.
voice is breaking. Okay, thank you.
Yeah.
So, any circuit, low voltage circuit, the maximum disconnection time is mentioned in the standard. Now, maximum disconnection time is not the only requirement. The full requirement is called as protective equipotential bonding and automatic disconnection of supply. The automatic disconnection of supply in the final circuit, for example, in case of a TN system, 0.4 second, TT system, 0.2 second. In the main distribution circuit, TN and TT, 5 second and 1 second. These are now specified in the standard. Now, how do you ensure it? First of all, you have to see that your installation is made. First, you have to find out what kind of installation you have made. There are system earthing called as TNC, TNCS, TNS, TT, and IT. Out of this TN, for example, for public distribution, the regulation is asking for TNCS. For industrial and commercial premise, TNS. If you follow a TT system, you have to use a 30 milliampere RCD for fault protection. That is the correct wording if we say. So public distribution TNCS, industrial premise TNS, and if you are using TT, then you have to have a 30 milliampere RCD. TNC is not allowed, not permitted inside the building. IT is for some specific application. Now I am showing a simplified TNS system. So it consists of the source, the line, the OCPD, and it is connected to the current using equipment. The neutral goes back to the neutral terminal of the transformer. The body of the equipment or the installation is connected back to the neutral terminal of the transformer. And this is a metallic connection, metallic fault return path. Now, what does this mean is the system which is followed at the moment in most of the industrial premises or resident or industrial and commercial and multi-storied buildings. 2 pit for neutral, 2 for body, 2 for main distribution board, 2 for lift, 2 for UPS, 2 for electronics. These are removed. It is actually the reason for electrical accidents and unreliability in the electrical installation is due to these kind of earthing. Separate. It's totally wrong. We have to find out the correct system earthing and do it. Now, similarly, this is also wrong. We have seen the picture in the IS 732. power earthing, lightning protection, separate. This is also wrong. Sometimes these are separate, then again interconnected under the soil. This is also wrong. You can find these pictures in various IEC standards. So what exactly is required is a proper system earthing. Now, for example, this picture is existing in IS 3043 since 1965. This explains how to make earthing of a DG and a transformer, or a supply incoming low voltage DG and a low voltage power supply from the utility company. You see here, engine, alternator, both are connected to the MET. Neutral is also connected to the same MET. Incoming EB supply, the PE conductor is connected to the same MET. Load side is also connected to the same MET. The same MET is connected to extraneous conductive parts such as pipe fittings, rebars, and so on. Then it goes to the independent earth electrode number 5020, chassis earth. This is figure number 38 in IS 3043, 2018. You can also see the same figure in figure 39, 40, 41. So basically, neither IS 3043 nor the regulation, nowhere so far in India, it is written to follow this kind of an earthing. Nowhere it is written. But by misinterpretation, we were following a totally wrong system, which is made right now. I hope my statements are clear. Now, regarding the fault loop impedance, you have a TNS system, and basically you have an MCB. Example, you have an MCB to trip. So MCBs, there are three types of MCBs are there generally, which we use: type B, type C, type D. Now, in a TNS system, once when there is a fault, which is shown there on the right side, the fault current will return back through this protective conductor, and now you have a closed loop. So the fault current is starting from the faulty position through the protective metallic protective conductor coming back to the neutral. It runs through the winding of the transformer, through the line conductor, returns back to the faulty place. So now you have a loop. The impedance of the loop is what we are talking about. And this fault loop is included in both the standards you have seen. The IS 732 is asking to go for a value of 2/3. Measured value or the actual value shall be 2/3 of the calculated value. Then this table is included in the National Electrical Code. For example, ZS in ohms, type C MCB, 32 amps MCB, 0.48 ohm. The impedance of the whole circuit has to be lesser than 0.48 ohm. Then only your 32 amps MCB will trip in case of a fault, earth fault. So this is the concept. Now it is also written, fault loop impedance shall be calculated during design. It shall be tested during selection and direction. It has to be checked periodically to ensure safety, and it has to be the first job of electrical safety audit is to make this measurement. So with this, probably we can go to the one more round of question answer if you have.
Sir, I have one question written to you.
Yes, Mr. Prafulla.
I have one question written to you, sir. You said
in the chat box.
I will repeat that. Measurement of loop impedance is made mandatory for DISCOM installations. Is it mandatory for consumer premises also?
Yes. Yes. It is made mandatory for the DISCOM. DISCOM's responsibility is up to the point of commencement of supply. At the point of commencement of supply, you have a protective device, which may be a cutout fuse or an MCB, or sometime MCB plus an ELCB or RCBO. So for example, that particular MCB should trip in case of any problem within the consumer premise. So you should do the checking. The DISCOM should do the checking. Now, inside the consumer premise, it is the responsibility of the consumer. So he also should do. Hope it's clear.
Sir, is it made mandatory in the NEC, very clearly written?
Of course, yes. It is there on the regulation. I will show it again.
No problem, sir. We will find it out.
1 minute. I will show it again. Now, let me see that. I hope it's clear now. Now, first I will read the first one. For example, earlier earth resistance, now have earth fault loop impedance sufficiently low to permit adequate fault current for the operation of protective device within the time stipulated in the relevant standard. Now, sub-regulation number 11, regulation 43, sub-regulation 11, earth fault loop impedance shall be tested to ensure the automatic operation of the protective device, and a record of every earth test made and the result thereof shall be kept by the supplier for a period not less than 2 years after the day of testing, and shall be available to the electrical inspector when required. So this is the responsibility of the supplier. It is nothing but the DISCO. The second one, 12, this is talking about the consumer. Every circuit belongs to the consumer. Hope it's clear.
Right, sir.
Is
Yes,
it
sir.
clear? Yeah, thank you.
आपका ये कहना है, हाँ, एक क्वेश्चन. नॉर्मली 2 टाइप्स ऑफ अर्थिंग, सिस्टम अर्थिंग मींस न्यूट्रल अर्थिंग एंड बॉडी अर्थिंग. तो आप ये कहना चाहते हैं कि बॉडी अर्थिंग की रिक्वायरमेंट ही नहीं है इन केस ऑफ एलटी?
No, everywhere you need body earthing.
नहीं, बॉडी अर्थिंग इज देयर, बट बॉडी मतलब अर्थिंग इलेक्ट्रोड से कनेक्ट करना जरूरी नहीं. एक आपने मेन अर्थिंग टर्मिनल बनाया, वहां पर आपने अर्थिंग कनेक्ट कर दिया, ग्राउंड से कनेक्ट कर दिया, देन एट एनी अदर प्लेस आपको अर्थिंग नहीं करना है. मतलब कनेक्शन करना है, अर्थिंग इलेक्ट्रोड से जो ग्राउंड से कनेक्ट करने की जो प्रैक्टिस है वो नहीं करनी.
Yes, for what? For what you need a connection to earth electrode in soil, the plate and pipe?
अभी तक जो करते हैं उसकी बात कर रहा हूं मैं.
Correct. I am asking a question back to you. For what?
Right, because it generally 2 types of earthing, equipment earthing. For equipment means for reduction of the touch potential. But if we are using TNS system, then it's okay. But if we are using TT system, then we have to have a equipment earthing at the panel also.
If you are using a TT system, if you are using a TT system, for example, you have an independent earth electrode, and electrically the neutral is connected to one earth electrode in soil, and the protective equipotential bonding of the building, that means all metals interconnected together to a common bus bar, is connected to a separate earth electrode. So basically your transformer neutral is separate, the consumer premise is separate. The fault current is intended to flow through the soil, through 2 earth electrode through the soil. Now, this was very much mandatory during the days of ELCB. Nowadays, ELCB is no more used in the network. Nowadays, we completely switch over to residual current device, RCD. In case of an RCD, even if you don't have any connection to earth electrode, in case of a faulty equipment, a person will touch, he get a shock, but the RCD will trip. Before that, before RCD, during the days of ELCB, if the earth electrode was not existing, ELCB will not trip and the person will die. So but the system has changed.
But even at present, in this case also.
Now, let me complete. Now, an earth electrode has been insisted in TT system. A 30 milliampere RCD is insisted in TT system. And an earth electrode is also insisted, because the idea is, in case of a fault, before a person gets shock, the system should trip. That is the idea.
Right, correct.
And that earth electrode value, if you are using a 30 milliampere RCD, the value can be 1666 ohm. Maybe 100 ohm electrode is also enough. That is there in the IS 3043. There is a table.
Now my one question is, in case of LT, it is okay. TNS system, it is okay. But where there is no neutral, And in case of ST, where panel 33 kV, 11 kV panels are there, in that case, when there is no connection of the neutral, existing in case of 11 kV,
there is no
or
neutral.
33 kV. So in
There
that
is no
case, you
neutral.
require, in that case, you will require earthing system for the touch potential, or that, what are the substation grounding, IEEE 80 and all that things.
IEEE 80, one moment, please.
In case of LT, it is okay. If we
One moment. I hope you have the IS 3043. You can go to clause number 20 and IEEE 80 for what voltage you are asking for? What is the applicable voltage? 11 kV or?
What will happen in case of ST panels? How person
what
will
voltage? What voltage?
No, voltage will be maybe 11 kV 33. The panels installed in the control rooms. Here you in TNS system, there is a neutral and you are connecting your system to neutral. But in case of here, in case of such kind of, there is no neutral, and you in that case is the panels, how person will be protected, because there is no fault loop path in that case, and in such case I think you will require separate earthing electrode for protecting that persons. For LT system TNS,
One moment. I am showing the IS 3043. I'm showing the IS 3043. One moment. Let me switch off my phone. It is ringing. Yeah. You see here, 27.2.4. In case of EHT substation. In case of EHT substation, means above 66 kV or 66 and above. There, when there is possibility of ground potential attaining high values of in the event of an earth fault, in this case, of course, you need to have an earth grid which is able to reduce the touch and step voltage. So this is applicable for 66 and above. First of all, IEEE 80 is a standard which is totally misused in India. IEEE 80 is applicable for distribution substation. The system in America is totally different than India. India, we have the low voltage distribution. In America, they have the HVDS, high voltage distribution. The distribution itself is in 20 kV, means every house or every building have got a very small transformer, and the secondary primary is 20 kV, secondary is 110 volt or 200 volt face to face, 220 volt face to face. So that 20 kV is coming from a substation according to their definition. The primary side is 66 or 132 kV. That means there is a substation in America. 66 kV is the primary voltage. Secondary voltage is 20 kV. That case, you need to apply IEEE 80. And that is the definition of substation in IEEE 80. Number two, IEEE 80 itself is not a standard. It's a recommendation. What you can do is, if you allow me 1 minute, I can show it to you. Now, sorry to use Google. IEEE Standards Guide. Okay, otherwise I will take you to another. So this is a blog which I am maintaining with Vidyut Suraksha. It contains all different electrical safety requirements. Okay, misuse of Indian standard and propaganda by IEEE 80. You can go through it. Now here, the GPR details are given. Here there is a link which explains you from IEEE. You see here, IEEE standards board. So IEEE, according to the IEEE website, IEEE has got the 3 type of documents. One is a standard. You see here, standard documents with mandatory requirement. Second one is a recommended practice. Documents in which procedure or positions preferred by the IEEE are presented. Guide documents in which alternate approaches to good practices are suggested, but no clear-cut definition recommendations are made. IEEE 80 is a guide. It is not a standard. Whereas in America, it's a guide. But what happened is in India, we use it as a standard. Now, the concept which is included in NEC is global earthing system. I have shown it somewhere. Global earthing system, the definition is you must interconnect all metallic parts in a building so that there is no touch voltage exists. Now, if you have a supply transformer, the supply transformer HT side and LT side also has to be interconnected. Also, please note that the NEC is applicable to consumer premise. It is not applicable to transmission or distribution system. I can show it if we have time. But Mr. Naresh, please look into this particular website. You will get a lot of information.
Okay. We will be in
Thanks
touch.
for the question. Now let us go to the next question. Mr. Algendra Singh. Oh, gentlemen, if anybody has got other questions, you can go ahead.
Sir, I have a
Yeah.
question.
Yeah, Prashant, you can go ahead and ask your question.
Sir, how can we reduce fault impedance of a earth loop system? So I think we have to use earth electrode for that. No? And second question is that, sir, in TN system, how much we can rely on the distribution neutral provided for decreasing our earth fault loop impedance? And third question is, sir, principle of working of RCD and overcurrent relays are different, no? MCB. So
Yes.
how can we use MCB in place of RCD for protection of earth leakage?
Mr. Prashant.
So these are my questions.
Yeah, if you all the three questions are answered in both IS 3043 and IS 732.
Okay, sir.
Both are there. Now the question is your second question regarding DISCOM. If the DISCOM can make a phase conductor reliable, why can't they make an earth return path also similar reliable? And if you look at the regulation 74, for example, for voltages up to 33 kV overhead line, they are supposed to make a metallic fault return path. And this regulation is existing since 1937. But the problem is the DISCOMs are not following the regulation. The problem is whether it is a problem of the regulation or it's a problem of the DISCOM. DISCOMs are not following the regulation. That is the main issue here. Now, the question is, in case of any accident, how the safety authorities such as the electrical inspectorate and the police, how they are going to act. If there is a violation of the regulation, then the DISCOM engineers will be in trouble. Hope you got the answer. Now, your first question, how much earth electrode is supporting to reduce the fault loop impedance? If you, the effect of reduction of the value by using an earth electrode, let's say 10 earth electrode and a very good conductor, probably 1%, 2%, not more than that. It's negligible. Irrespective of, instead of making research on the earth electrode and chemicals, the best way is to make a proper metallic fault return path, a reliable metallic fault return path. So, thank you.
Okay, thanks.
So, Praful, you can go ahead and ask your question.
Sir, my question is, you said now the electrodes, earth electrodes are not required and we can have MET. But finally, MET, as you shown in one of the pictures, it consists of a mesh. We used to do mesh kind of earthing system with the help of grid of earth strips with 2-3 earth electrodes. So the same concept is used in MET also. It is nothing but the same thing, or MET is without any earth electrode at all, and it is only a existing metallic parts of the building, and same can be used.
It depends on the application. It depends on the application. you are talking about a residential application or a low voltage residential application or a low voltage industrial application or a high voltage application? If you can clarify that, then I can answer.
Sir, it is, I'm from Discom, and for distribution network in substations, we develop a grid of earth strips supported by a few earth electrodes, and that is how our TNCS system works. Earthing system is there.
In the substation, if you are making an earth grid with electrodes, vertical rods, then in the TNCS system, it only answers the first one, T. That means the neutral you are connecting to a reliable system, T. But NCS is from the transformer or from the substation up to the consumer premise and inside the consumer premise. So N and C depends on the distribution. For example, if it's an overhead line, along with the phase and neutral, you can make it in two ways. One is a fifth conductor, which is interconnecting all the metallic poles. Also the guarding, if you have everything interconnected, a metallic fault return path is required as per the regulation, the new regulation 74, I think the old regulation 72. If you have a underground cable, armoring of the cable can be used as a metallic fault return path. And at each of these junction boxes, consumer boxes, you have to make additional earth electrode. Within 1 kilometer, you need to make 3 connections to earth electrode. By this way, you can make a reliable TNCS. But what is most important is, at the consumer premise, you must interconnect the neutral and the earth terminal. I repeat, at the consumer premise, neutral bus bar and earth bus bar must be interconnected through a link. Then, for three-phase consumer premise, the earth terminal also has to be connected to an earth electrode. So, by making a grid only at the substation, you are making T.
So, sir, we are following the same. We are following this same system what you explained.
Oh, very good, very good. But I have not seen the link between neutral and earth at the consumer premise.
Yeah, that was missing. It was not the customer, consumer earthing was separate, and our earthing in the meter room was separate. Now it is made mandatory, I think.
No, if the link between neutral and earth in the consumer premise is missing, then it is not a TNCS network. It's an undefined network. It is neither TNC nor TT.
Sir,
so at the moment, we cannot say if this link is missing, you cannot say it as a TNCS.
Sir, at the moment, see, we have a point of supply. So till the point of supply, my neutral and earth is connected, but the customer connection is separate. So he will have his own separate earth connection, and his earth connection was not connected to my earth connection solidly. That link was missing. Now it is, I think, made mandatory here.
Correct, correct. Now it is made mandatory. You should allow it, because in last 1 year I have come across at least 6 to 7 cases, especially in Bombay and Mumbai and Ahmedabad area, where the Discom is not really allowing to make this connection. But once when we told them with technical reasons, they allowed it.
Yeah, I got the point, sir.
Thank you, sir.
Mr. Alkendra Singh, any question from your side? You have raised your hand. Also request everyone to put your camera on, including Gopal sir, if you could also put on your camera, I'd be grateful.
Yes, sir. Yes, sir. Can you hear me, sir?
Yes, Mr. Singh. Yeah.
Hello. Am I audible, sir?
Yes, loud and clear, sir.
Sir, I wanted to know that this fault loop impedance, how it can be measured. Is there some instrument especially meant for this? Digital equipment?
You just Google fault loop impedance meter, you get the answer.
Okay, okay, sir. Okay, thank you, sir. Thank you.
Hope there is no further question.
Any further question? There are, yes, Ashwini Kumar sir. You can go ahead and ask your question.
Yes, Gopaji, good evening. And my colleague has asked a good number of questions from you already. So there is one question, just as you have explained, that till point of supply for distribution, this fault loop impedance measurement and retention of records, it is mandatory. But what I am giving to understand, for customer, it is not mandatory and it is kind of choice that's been given to them, but it is recommended, right?
Can you repeat the question? For the customer, it's not mandatory. I don't understand that.
For customer installation, for customer side wiring, etc., even it is mandatory that they perform this fault loop impedance, prospective fault current measurements, everything.
Sir, there are two requirements. One is for the supplier. So supplier, wherever you are ending your supply, or you see the point of commencement of supply, at that location, the supplier should test, because the supplier is also providing some protective device, such as a fuse or an MCB. Am I correct, sir?
Yeah, I understand that is, I use the word point of supply. So till point of supply, the supplier, supplier scope is there. So it is mandatory that we have understood.
Yeah. Now, the circuits inside the building, it is the responsibility of the customer, because a supplier cannot go inside a consumer premise and do the testing, you know.
Yeah. So it is mandatory or not mandatory for customer to provide the details to utility?
This was a big debate during the initial days of regulation, but now if you look at the sub-regulation, one of the sub-regulation, not the earthing part, but the testing part, it is requested to provide all the test reports to the DISCOM. Now we are going to have some trouble, such as, the testing has to be carried out by the chartered electrical safety engineer, but the state governments have not implemented chartered electrical safety engineer until now. The number of engineers are less. That is the next challenge.
But there are licensed electrical contractors who can do that, right?
Gopal sir, here just I wanted to add one more thing. Now that the more and more people are, am I audible?
Excuse me.
Your sound is very less.
Gopal sir,
Quite
am I
less.
audible? Am I audible?
Hello, my question is not over. Am I not audible?
Yes, Mr. Ashwini Kumar. You can go ahead and ask. Chandrasekhar sir, you can just wait for a moment. Mr. Ashwini Kumar still yet to complete his question. Go ahead, Mr. Ashwini Kumar.
So, Gopaji, as just you have said, that part, the customer part, so there have been big debate, and so what is the final outcome? So it is kind of choice that's been given to customer?
No, to the DISCOM.
Okay, so you leave it to DISCOMs to get the things from customer and put the compliance.
Finally, the DISCOM should ensure that this is carried out, means either the DISCOM can do this testing directly, or DISCOM can rely on the self-certificate of the consumer, provided the consumer made the testing with the help of a chartered electrical safety engineer. Now the question is, if chartered electrical safety engineers are not existing, who will do the test? Of course, the first part, DISCOM. This is what I told. This is going to be another Pandora box. We are not clear how
licensed electrical contractors can do it.
Ashwini Kumar, your voice is breaking.
Whether the licensed electrical contractors can perform this?
That is not clear. That is not clearly written. Only the chartered electrical safety engineer can do this.
Name, if I can ask your opinion, what your opinion would be?
My opinion is, first of all, at the point of commencement of supply, if the DISCOM is ensuring that, then that's enough. inside the consumer premise. For larger consumers, of course, they can do it, but for smaller consumers, it will be handling millions of customers will be a tough job. But at the point of commencement of supply, if you ensure, that itself is a big improvement.
Okay, fine. Yeah. Thank you very much.
Mr. Chandrasekhar, you can go ahead and ask your question. Please.
Yeah, I'll just add to what we are discussing now. Gopal sir, it's a wonderful session, I would say. Here we are doing a lot of rooftop solar power plants for the residential and commercial customers. When it comes to commercial customers, adhering to the earthing conditions and all, as per CEIG regulations, we are doing it. Number of earthings and whatever they are asking for. But when it comes to residential solar, the cost is not that suitable for residentials, but people are going for it. And here we have a typical scenario. 4 discoms are owned by Tata Power, to be precise. There is no particular guideline how many earthings are required for a residential solar, let's say up to 10 kilowatt and all. So how this NEC is going to impact, because we see a clause of solar thing also added in that. So any particular thing is there, how many earthings are required, 2 or 3, or what is there?
One moment. If you ask for a low voltage consumer premise, let's say, for example, a rooftop installation, was it the question?
Yes, sir. True.
In that case, the consumer premise and how many earth electrodes is the question, right?
Correct, sir. Correct.
0.
0. Okay. And the existing
what is required is what is required is, I think, part 7.
Hello, are you there, sir?
Gopal sir, we lost you.
Yeah, I think.
He will reconnect. Okay, yeah. Okay, fine. Sir is connecting back. System got disconnected.
Sorry, I got disconnected in between. So, I don't know who asked the question. So, gentlemen, you can refer to NEC.
Yeah, Chandrasekhar, this side. Please.
Yeah, Mr. Chandrasekhar, you can refer to NEC. In the part 8, there is a picture. You can refer to that. I have the picture. Just now, I will share it to you. One moment, please. Oh, you have to make me as a host, Mr. Rajesh. Or probably the host is, I don't know who is the host. Mr. Naresh, you are the host. You have to put me as a
Yeah, Mr. Naresh is become host after you.
How can I put? Yeah. Can you guide me? How can I make?
You
this?
click my name. There you will see 3 dots, and you have to put.
Okay. I have made you host.
Yeah, thank you. Thank you. Now I can share the screen. So this is the picture. Sorry, my internet connection is not very stable.
That's okay, sir.
So this is the picture. You can see here. You see on the PV generator, PV SPD, there is a bus bar. The bus bar is connected near to the inverter. There is one more bus bar which is connected to the MET of the building, and the MET is connected to the earth electrode, depending whether you are going to have TT, TN, CS, whatever. So this is how it is.
Yes,
you can find the picture in NEC.
हो गया है क्वेश्चन चालू है क्वेश्चन आंसर हो गया ऑलमोस्ट खत्म होने को
Hope the question is answered.
I got the answer. Thank you very much.
email बंद है
So Mr. Rajesh, over to you.
Yeah, thank you. Thank you, everyone. I hope all your doubts has been answered through this webinar. Any further question, if anyone has?
Sir, where can I get the NEC copy, latest NEC copy?
You can download it free of cost from BIS website. So I will just post the link here. One moment, please.
And also your contact details, sir. Gopa sir. We would like to be in touch with you.
Oh, yeah. One moment. I am just posting
I had
this.
shared Gopa sir's contact,
So it is BSB Edge. So I just put it on the chat box. You can make a note of it. So my mail ID and the phone number is also put by Mr. Rajesh. The presentation copy I will send to Mr. Rajesh. He will send it to you all the participants by email, because it will be too tough to send it. Sharing will be a tough job. Over to you, Mr. Rajesh.
Yeah, thank you. Thanks all participants for your registration. I hope all your doubts has been cleared by Gopa sir, and we keeps on doing such webinar, interactive webinar in forthcoming. There is another on 10th and 21st August. We'll share the details soon, mainly with electrical code, mainly the audit part, and the other details will be shared shortly. Before we depart, I just like everyone to just put on your camera. Most of the people not yet put the camera. The reason is we do, publish this photographs along with webinar information in our monthly journal and weekly updates. So I just take a 2 minutes before we say goodbye to everyone. Thanks a lot. Really appreciate all of your time and efforts. Thank you.
Thank you very
Mr.
much.
Rajesh, I also need the chat box of all the people so that
Yes,
if required,
yes,
we
yes.
can also answer to their questions later.
I will share that with you shortly. Just give me a moment. I just take a
Oh.
print screen.
I can see a company with power. A lot of people are sitting and watching. May I know
Absolutely.
which company is it?
Can you power? What is the company name? If you could let us know. Hello. This is where exactly? Where are you all from? Hello. Can you just put on your audio and just say thanks a lot for joining in? Thanks a lot for joining in. This is from NCRTC, I believe.
Okay, this is Electrical Inspectorate Nagpur. Okay.
Yeah, yeah. Thank you. Thank you. Thanks a lot. Okay, we end this session. Thanks a lot.
One moment, Mr. Rajesh. I hope
Yeah.
Electrical Inspectorate Nagpur, I think we met and the same subjects was discussed 2 days in Nagpur. Hope you remember, we made the same explanations in Mahindra and Mahindra. So it's nice to see you again. Thank you. Over to you, Mr. Rajesh. You are on mute.
Yeah, thanks a lot. And we end this session. Thank you, Gopa sir, and looking forward to seeing you soon. Take care. Have a great weekend to everyone.
Thank you very much, Gopa sir.
Thank you, sir. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.